viewers to another episode on AS your G12 exams. So this is the 9th episode in a series of episodes that are focused on the 2020 GCE Science Paper team. So if you haven't seen the last episodes, please check out on our YouTube channel. So let us look at question C1 from section C. We're expected to answer 2 questions out of 3 and each question carries 10 marks. Question C1. Clean dry air contains about 79% by volume of nitrogen. Name the gases which make up the remaining 21% by volume. So let me just answer A from here because we have enough space. So we have nitrogen, oxygen, then we have argon, then we have carbon dioxide, then we have other gases. These are the composition of the clean air. So this one has been given to us, but the actual percentage is about 78%. Then oxygen is 21%. Then we have argon about 1%, which is 0.9%. Then carbon dioxide 0.03%. Then the remaining is 0.09%. So these are the composition of the clean air. So you get these. So if you can name either oxygen and argon or oxygen and carbon dioxide, or you name all the 3, you get these 2 marks. So it's best that you name all the 3 that are remaining. Question B. A sample of polluted air was found to contain both nitrogen dioxide and sulfur dioxide. State the major source of each of the pollutants. So we are talking about nitrogen dioxide and sulfur dioxide. So let us just go where there is space. So this is B. So for B, we start with nitrogen dioxide. So nitrogen dioxide is as a result of reaction between air, hot air, and the nitrogen. So the sources are what? Car engine. So this happens when nitrogen and the air in those hot engine reacts, they form nitrogen dioxide. Then secondary is in the hot furnace. Again in here, the hot air is going to react with nitrogen to give us nitrogen dioxide. Then we move to sulfur dioxide. So sulfur dioxide comes mainly from burning of fossil fuels. That's the source of sulfur dioxide. Let us move to the next question. Roman numeral 2 of B. Describe a test which could be carried out to confirm the presence of sulfur dioxide in polluted air. Okay, so we come here. Roman numeral 2 of B. This is Roman numeral 1. So the test that can be done to test for the presence of sulfur dioxide is by using potassium permanganate solution. So sulfur dioxide is passed through the potassium permanganate solution. So if it is sulfur dioxide, the solution which is in pink in color or pink violet in color, which is potassium permanganate, will lose its color if indeed the gas which is passed there is in sulfur dioxide. So the answer, it can be detected by using a potassium permanganate solution, which is pink violet in color. So if sulfur dioxide is passed through the solution, when the solution decolorizes, so loses color, then the gas is sulfur dioxide. So that's a test that you need to conduct. Once you do this, you are good to go. Question C. Respiration and rusting are chemical processes which involve one of gases in air. Show clearly by chemical equations how this gas takes part in each of these reactions. So we have two reactions, which is respiration and rusting. So what you need to do is show the chemical equations. Then, since these are connected, they are all 4 marks. Roman numeral 2 of sin. One method of preventing rusting is sacrificial protection. Describe how this method of rust prevention could be used on an oil pipeline and explain how it works. So that's what we need to explain. So let me just go there. We'll start with the chemical equation. So we're going to start with respiration, then rusting. So let me look for space. So C, number 1 is respiration. That's what we need to show, the chemical equation. So what is the chemical equation of respiration? So the chemical equation of respiration is we have glucose. We react it with oxygen. Then we are going to end up with carbon dioxide plus water. So the chemical reaction glucose is C6H12 0, then 6 down here. So this is 0 is oxygen. Then this is reacted with oxygen. So it's going to give us carbon dioxide, which is gas, then plus water, which is liquid. So as per tradition, I need to balance this equation. So I have 6 carbon here, then here I have 1, so I can introduce a 6 here. So we have 6, 6, 6 is balanced. Then in terms of hydrogen, I have 12 this side, here I have 2. So for me to balance this, I need to introduce a 6 here, so I'm going to have 12, 12, so it's balanced. But in terms of oxygen, I have 6 plus 12, which is 18. This side I have 6, so the only way I'm going to have another 12 here is to introduce a 6 here. So I'm going to have 6 times 2, 12 plus 6, which is 18. Then this side I have 12 plus this side 6, 18. So that is balanced. Then we are good to go. So this is how you balance this equation. So this is for respiration. So next we need to write the rusting chemical equation. So the next question is, what is rusting? So rusting is ideally the slow oxidation of iron by atmospheric oxygen in the presence of water. So generally speaking, we are saying when you react iron with water, what we get is iron oxide. So this iron oxide is what we are calling rusting. So we have iron, which is solid, then it's reacted with oxygen gas in the presence of water. Then we are going to end up with this iron plus this number of water molecules. So this is a solid. So even here we are introducing N. So N is the number of moles. So this N is the one which will be here. Then this is a dot. So this is the chemical equation of the reaction of iron with water to give us the rusting. So this is C Romani numero 2. So the first thing is what we need to do is we need to understand what is sacrificial protection. So we are saying sacrificial protection is a method used to protect buried pipe lines from corrosion, which involves attaching sacrificial anodes to a pipe lines coated steel. So now what happens is the sacrificial anodes are more electrically active than steel. So corrosive currents exits through the anodes instead. The anodes instead of steel pipes. So that's what happens. So what is going to happen is you're going to use the anodes. These anodes are the ones that are going to act like a sacrificial lamp. So there will be sacrificial lamp. Instead of corrosion happening to the pipelines, it's going to be going through the more electrically active anodes than steel. So in that case, the steel pipeline, which is made of iron mixture, is going to be protected from corrosion. So this is how it works. So once you do this, you are good to go and you get these 10 marks. So thank you for joining me in this episode. Please join me in the next episode as I look at question C2.